Okay, question 6. This is looking like our logs and exponentials. This one is your classic. So I've got an exponential function. There's not a negative in here, so really all you've got is a classic function like that. That'd be y to the ax. So any kind of base. In this case, our base is e. Euler's number pops up quite a lot in nature, but don't worry about that. That really is just any number. It could be 2, 3, 4, 5, 6. Doesn't matter. The point is, if it was a 2, it's doubling each time. If it's a 3, it's tripling. 4, it's quadrupling. And e, 2.7, so it's almost tripling each time. Okay, but that's what's happening with this function. We're asked to state the number back to your present start. Okay, well, what's so different from this to this is we've got a number in front, yeah? We've got a k in front of it. And what happens there is, if k was just 1, we would usually go through here at point 1, because at this point x is 0, so when x is to the power of 0, a to the power of 0 gives you 1, so you're just left with k. So when k is 1, that's 1. When k is 2, we pass through 2, etc., etc. So this number here is always your starting point. It's always the beginning. When time is 0, this is how much I've got, bacteria-wise or whatever-wise. And then as time goes on, this function tells you how it's growing or decaying. If you've got a little negative up there, your function is a decaying function. So you're interested, it gets smaller and smaller and smaller with time. Okay. So anyway, let's get rid of that. Didn't mean to get rid of all of that. Yeah. And I'll get rid of that little negative. So your first one's quite an easy one. You're just saying that you've got 200. That's the starting position. Now calculate the time taken for it to double. Okay, well, start at 200. Double that is 400. So I'll substitute that into here. So 400 is 200 e to the negative 0.107 t. And we just rearrange now. So 400 divided by 200 is e 0.107 t, which is obviously just 2. Nice one. And this is where you're in a bit of pickle. You're thinking, wait a minute. I know how to rearrange stuff. I don't know how to get this down. I can do the opposite of a multiply, a subtract, but how do I get that down? And that was our new rule that we learned, which was that we take natural logs of both sides of the equation. So I take a log, I'm going to end up with e 0.107 t. And what happens there is that the logs cancel out, the log and the e cancels out, and I'm left with natural log 2 is equal to 0.107 t. That's our fancy new rule that we've learned on this topic. Now you can think on that a few different ways. So natural log is just log base e. So if I had that e 0.107 t, what that really means is, and I'll write the easy one that we all remember, log 10, 100 equals 2. What that says is 10 to the power of what is 100? 10 to the power of 2 is 100. So this is saying e to the power of what is going to give me e to the 0.107 t. Yeah, e to the power of what is going to give me e to the power of 0.107 t. So your answer is just 0.107 t. In the same way that up here, I could have rewritten instead of 2 there, I could rewrite that and say that's 10 to the 2 is equal to your 100, or I could actually, better still, why not I rewrite that 100, I'll write that, that's just 10 to the 2, isn't it? Yeah, so 10 to the 2, there's your 10 and 2, there's your answer there. So that number, that power, jumps over here. Yeah. So different ways to think about it, but the easiest way to think about it really is just that these cancel out and you're left with the power. Okay, different ways to think about it. Anyway, so now at this point, you can see you've got log 2, and you're going to divide by 0.107, and that is, I was getting ahead of myself there, too busy now thinking about breakfast, is equal to t. Fantastic. I'll just check the answer for that one. Yep, so that's going to give me 6.5 hours. I'll just round that to 6.5 hours. Very good. So for our marks for this one, you're getting a mark for interpreting here. Obviously, you get a mark for your first bit, but this is going to be worth a mark. taking logs of both sides, that's giving you a mark, cancelling out, and then your final answer. So I think this is an excellent question, especially that first bit. There's 5 marks in total for not a lot of working actually. But the trick is knowing that taking the logs of both sides can bring that down. Now, yeah, it's if you want to think about it this way to try and explain what you're doing, that's fine. But if you want to just in your head say, I know that ln and e will cancel out, that's fine too. Okay, so whatever works for you, whatever works for you. Anyway, I hope that was helpful.